In the previous chapter, we discussed policies in reinforcement learning, particularly deterministic policies and stochastic policies. The chapter finished with the question about how we can determine possible future rewards from being in a certain state. This is done through the value function. Think of this as looking ahead into the future and figuring out how much reward you expect to get given your current policy. In other words, the current state to action mappings in the case of a deterministic policy, or state to action probabilities in the case of a stochastic policy. Let's use another example. Say the agent is approaching a corner. The algorithm queries the policy about what to do, and it says to accelerate hard. The algorithm then asks the value function about possible future rewards from the result of accelerating hard. Unfortunately, the results are not too good, as it's likely the agent will go off track in the future due to its hard acceleration into the corner. So as a result, the value is low and the probabilities of that action in our stochastic policy can be adjusted to discourage selection of the action and getting into this state. In the case of a deterministic policy, a different action with higher future reward may be selected for that state instead. This is an example of how the value function is used to critique the policy, encouraging desirable actions while discouraging others. We call this adjustment a policy update, and this regularly happens during training. In fact, you can even define the number of episodes that should occur before a policy update is triggered. Just as a side note, in practice, the value function is not a known thing or a proven formula. The reinforcement learning algorithm will estimate the value function from past data and experience. Stay tuned, and in the next video, we'll be looking at the differences between PPO and SAC.